If you listen carefully, there's a sound off in the distance. A beat of a drum from far, far away. It's getting louder, little bit at a time, little bit more steady, but it's definitely growing, and it's coming our way. I'm Mark Sponsler. Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 15th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. All right, let's get to work. Looking at significant wave heights from the North Pacific Ocean, we see another in a series of local gales trying to develop off the coast of central California, another gale north of that off of Oregon falling southeast, yet another gale trying to develop in the northwestern Gulf of Alaska, and more energy behind that. None of them particularly strong, but all part of this consistent pattern that has been going on for over 2 weeks now. Let's get into the details. First off, we'll do a quick look at current conditions. We're looking at the Half Moon Bay buoy, number 4601 off of Northern California. We're looking at all the energy present hitting that buoy. Long period energy, this is anywhere up 30.3 seconds, super long period energy, which there is none, all the way down to 5-second period. That's pure wind chop. Real ground swell starts at about 13 seconds. We see a bump out here at 20 plus seconds. That's energy from a gale that was previously west of the dateline. We see a whole bunch of other local energy in the 12-second period range, something like that. Putting it all together, primary swell, 9.3 feet at 11.7 seconds from 284 degrees. That's the local swell. Surf estimated at 10.9 feet from that, so that's double overhead or so. That's probably about right. And then there's also some energy. It's not showing up here in the calculations, but also in the 20-second period. Looking down in Southern California, the north end, buoy 46053, East Santa Barbara buoy, we see just the local swell, whole bunch spread anywhere from 5 seconds up to 17 seconds, but most energy focused on 6 feet at 12 seconds from 266 degrees. Surf estimated from that about 2 feet overhead or 7 foot. And then down at the south end of Southern California, buoy number 191, Point Loma South. Again, same sort of profile, a whole bunch of wind swell and some ground swell mixed in there. Surf estimated, or swell estimated 5.2 feet at 13.4 seconds from 268 degrees. Again, about 7 foot, 2 feet overhead. And then looking in Hawaii, North Shore, Waimea Bay buoy number 106. Same sort of profile. Now, this is different swell energy. Most of it focused in the, we'll say, 15.4 second range. This is swell. The 20-second period swell you saw in Northern California, this is that same swell, but it's already past its peak, but still quite present at the Waimea Bay buoy. Primary swell, 6.7 feet at 14.9 seconds from 324 degrees. Primary surf from that swell, 10-foot Hawaiian, we'll say a little bit over double overhead, something like that. So let's see where this swell is coming from. Now, this is the giant storm number 2, swell number 2, that has already passed California for the most part. Little remnant energy from it, still present, but this was the one here. So let's get oriented. Japan, Kuril Islands, Kamchatka, Aleutians, the mainland, California right there. This system started developing. We're back on Wednesday, January 11th. Started pushing to the dateline, had 40-foot seas for a brief minute, and then pretty much flared out. Seas down to 29 feet on Thursday night, the 12th of January, but continued to percolate or circulate in the, we'll say the North Dateline region into about Saturday. Then it started fading out completely. You can see the swell front from it. It started hitting Hawaii. It was Saturday night, Sunday morning, and now starting to show along the U.S. West Coast at select buoys, mainly north of Point Conception for the moment. All right, so that's current conditions. Let's go look to the future. We're going to start looking at the jet stream. These are winds up about 30,000 feet. These winds help support the formation of gales when they drop into a trough. just like there, a dip in the jet. That helps create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. Of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. Swell, when it hits your beach, turns into surf. So we have a trough here off the U.S. West Coast. It's just been persistent for 2.5 weeks now, since that was sometime before Christmas, and is continuing for the moment. But of most interest, there's a break here in the jet. Now notice the jet is consolidated, still pretty active, pushing off Japan. But this split here in the jet suggests some weakness in the upper level circulation. We'll get into that in a minute and how that happens. But a lot of it has to do with this thing called the MJO and westerly winds and all that kind of stuff that happened down here in the far west equatorial Pacific. All right, so let's put this into motion. So we get into Monday, trough pushes into California. Again, this atmospheric river, that's what this is about, is the jet stream. Winds in the jet stream pushing directly onshore in California. They drag all kinds of moisture from across the whole Pacific with it, and also provide lots of energy to support gale development. And this is where we've been for 2+ weeks now. That will continue on Monday in California. The break, though, starts building, and notice the jet looks like it's trying to split. Part of the energy goes north, part of it goes, well, not really south, but just sort of due east. And that is probably a good sign for California, suggesting when you get these splits, you get high pressure. And in between the two branches of the jet, when you get that, that tends to not support precipitation. And I think California has had enough of the wet weather, at least for the moment. As we get into Tuesday night, Wednesday, another trough starts building here over the North Dateline region, and yet another trough off the Pacific Northwest. As we get into Thursday, now this looks like more of a familiar pattern, a La Nina pattern, when the jet goes up, falls down the coast, you get these backdoor kind of fronts, colder temperatures, not nearly as much precipitation, pretty good for light snow, light quality, good quality snow production versus heavy wet snow. Okay, but notice winds picking up to 190 knots off Japan. This is as we get into Thursday. And as we get into Friday, you can see the beginning of this pattern, a whole new pattern now. Jet making it to about a point north of Hawaii, then splits. You got the big split, high pressure in between. Now, because the high pressure is out here, that will likely suggest north winds along the California coast, unfortunately. Anyway, another trough starts building on Saturday, likely supporting gale development. Look at this giant ridge building here over the Gulf of Alaska. Total different change in pattern. And this is Sunday, a week out. Backdoor trough pushing down the U.S. West Coast, and we're out. There's 180 hours. Now I'm going to wrap this completely around. We go from that with the jet just streaming onshore to a week from now. The jet, very powerful, making it to a point north of Hawaii, then splitting. This suggests that the majority of storm development will be over in this area of the Pacific, and California at some point, if the jet can just push either a little bit this way, or the split in the jet, either push a little east or push a little west, then we'll get lighter winds over California and a much better pattern. All right, let's go take a look. Surface level pressure, surface level winds. As expected, there's a trough right here. Literally, you can see the storm track following the jet stream. A little bit of a gale trying to wind up off of Central California with 35-knot winds. Another gale up here off the Pacific Northwest with 45-knot winds, but over a really small area. Then some other sort of blob of energy with 30 to 35-knot winds pushing over the dateline. As we get into Monday, the trough push and associated energy pushes into California. Low pressure trying to develop in the Gulf of Alaska, not looking particularly good. Another system developing off Japan. So we get into Tuesday, the Gulf system continues. That could potentially, with 30 to 35 knot winds, could generate some swell. This one way more interesting with 45, almost 50 knot winds targeting Hawaii. Whoop, in fact, we go back there. Little pocket of 55 knot winds on Tuesday morning. It continues lifting north east up into the northern Gulf of Alaska on Wednesday, still with 45-knot winds, likely generating swell for Hawaii and the U.S. West Coast. Right behind it, here comes another one. The machine is well primed. So we get into Thursday, 45-knot winds taking aim on Hawaii, building to 50 knots on Friday, and even maybe a little bit more. Then the split is somewhere right here. Look at the high pressure starting to bloom, 1032 millibars, north winds along the north and central California coast. And yet another low starts building off of Japan as we get into Sunday. In fact, what they call a complex low, two cores, one fetch, 45-knot winds aimed off to the east, another core developing with 40-knot winds, and continuing as we get into Sunday night a week from now. So swell production does not look like an issue. The concern though here, high pressure, 30-knot north winds along the California coast. We'll get into that in a minute. All right, what's the effect of those winds on the ocean surface? Well, we got 20-foot seas off of central California. What is that, like 27-foot seas off of the Pacific Northwest, and 23-foot seas developing on the date line, pushing into the Gulf. They're building to 24 feet as we get into Monday. These seas start, this is just going to be a jumbled, warbled mess north of Point Conception. You want to be south of Point Conception. At least there's some protection there from the Channel Islands. More swell being generated as we get into Tuesday from this Gulf low, 21-foot seas for North California. But here's the main interest. 38-foot seas developing on Tuesday night. Fading some while pushing over the date line on Wednesday, but still, what did we get there? 38 feet again. So swell from that, you can see the swell front working its way to the east on Thursday and swinging into Hawaii towards the U.S. West Coast. Here comes the second system building with 36-foot seas. Yeah, peaking at about 36 feet, pretty close proximity to Hawaii, aimed directly at the islands, probably some decent-sized swell from that to be expected. And then Sunday, yet another system starts building off Japan. Maybe not as big as the previous two, but still a swell producer. Local winds for the California coast and the Hawaiian Islands. Well, the models make it look like it's a light westerly flow, and maybe it is, but the sea state is so agitated with just non-stop south winds for 2+ weeks now. It'll take days for that to settle out. Even if winds go offshore, it'll take a little bit, but that's not even in the cards. Here's the next low winding up with 30-knot winds in some direction, south or southwest for the California coast. Trades for the Hawaiian Islands as we get into Monday. Tuesday, though, notice wind direction changes for the first time in weeks. Northwest winds driven by building high pressure right here, clockwise flow, driving that. More or less trades for the Hawaiian Islands. As we get into Wednesday, northwest flow lightens up for a little bit early Wednesday morning. A quick little backdoor front looks like it's trying to set up here off of Cape Mendocino. Light winds, we'll say roughly trades for the Hawaiian Islands. So we get into Thursday, high pressure starts building again. Northwest winds at 15 to 20 knots. A light wind regime for the Hawaiian Islands. You get into Friday, more of the same. Northwest winds for California, sort of a southeasterly flow for the Hawaiian Islands. Saturday, high pressure really starts building, and you can see just the wrapping around southeast trades for the Hawaiian Islands, and you have this local low with a cold front right there just sucking winds out of the south. California northwest winds at 15+ knots, something like that. Sunday, northwest winds build even more, 30 knots north of the Golden Gate and probably 15 knots south of there. Lighter wind regime for the Hawaiian Islands, and we're 180 hours out, and it's nuking north winds for California. It goes from nuking south winds to now nuking north winds. Not really the pattern we want to see. Hopefully the core of this low either moves onshore or pushes further out, but sitting right there, not the ideal place to be. Right, precipitation forecast for California as we get into Sunday night. Yes, snowing in the Sierra, rain along the entire coast down to San Diego, and continuing through the evening into Monday morning. Pretty heavy snow as we get into Monday morning for the Sierra, but you can see a clearing pattern and high pressure starting to set up. So we get into Tuesday, finally a dry day for California. Maybe one more front, backdoor front, pushing down into the Golden State as we get into late Wednesday night with snow in the Sierra, but not heavy, and the rain pretty light and quickly out of here. And then as we get into Friday, dry air sets up, and that's pretty much it for the foreseeable future with bulletproof high pressure setting up. Looking at rainfall totals for at least the California area, in the San Francisco area, by the time this is all over, we'll say sometime on Monday or Tuesday, we'll be close to 100% of our normal seasonal winter rainfall, and the snowfall in the Sierra will be very close to 100% of normal. And we think there is more coming long term, but there's going to be a bit of a break before that. Snow forecast dashboard for Olympic Valley, formerly Squaw Valley. For the first time in weeks, these bars have been off the top of the chart in the 100-inch range. Finally, we're settling down. I mean, I guess that's a good thing. I'm not sure. Probably the snowpack needs to stabilize a little bit. We have no belief that this is over for the season. We think there is much more coming, but we're going to get into that in a minute. But for the immediate future, for the next couple of days, maybe a foot of snow, and then maybe a little bit more after that, giving us 20 inches for Olympic Valley. Kirkwood, by virtue of just being higher in elevation, pull out maybe 26 inches. And Mammoth, about 15 inches. That's for the next 10 days. And then taking a look at the snow level. So this is the base of Olympic Valley. This is the top. This is about, 6,200 feet. That's the parking lot there. And up at the summit at Granite Chief, or maybe the top of Palisades, it's about 9,000 feet. We see snow level way below the base, down about roughly averaging 4,000 feet, but in the evenings going down to maybe 2,000 feet or even less. A little bit of a warm-up on January 21st and 22nd, then falling right back down, maybe warming up a little bit after that. But precipitation amounts, well, you can see the blue bars is where we actually get snow. The red is the total accumulation. So during the actual precip event and where the yellow lines are, that sort of indicates maybe where it is as well. Snow level way below base, good for snow production and light powder. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation, the MJO, and the El Nino Southern Oscillation? These are the two oscillations that have the most effect on Pacific weather, specifically swell production for Hawaii and California. We're going to start off by looking for signs of the MJO, the Madden Julian Oscillation, that periodic weather oscillation that rotates around the planet from west to east on the equator. The active phase of the MJO on one side of the planet, the inactive phase, its polar opposite or its evil twin, on the other side of the planet. They rotate west to east around the equator. The active phase is the one we're interested in. It is effectively a low pressure system. When it pushes across the Pacific and takes 6 weeks, something like that, to go from the West Pacific to the East Pacific, it reduces trade winds. It also imparts energy to the jet stream. When the jet stream is energetic, it feeds storm development and also can produce atmospheric rivers pushing into California, makes rain and snow and all that kind of stuff. The inactive phase does the exact opposite. It's a high pressure system. It dries things out. So what we see that split in the jet stream we were talking about earlier, we suspect that is due from a transition from what has been the active phase of the MJO, and we're going to get into this in a minute, but the active phase, if there ever was an active phase and you wanted to visualize its impact on the jet stream, well, the past 2.5, 3 weeks are the poster child for that. Atmospheric rivers, unstoppable surf, out-of-control surf, and lots of precipitation. Anyway, so the active phase, when it moves over the West Pacific, also reduces trade winds. The inactive phase feeds trade winds. The inactive phase being a high pressure system, high pressure generates this kind of persistent trade wind pattern. The inactive phase sets up low pressure across the Pacific and reduces trade winds. So we're looking at data from the TAA buoy array, series of buoys strung across the equator used for monitoring El Nino. This is data from them. This is the East Pacific here. This is the West Pacific here. 0, that's the equator. 180, that's the date line. Over here, well, California is about 120. Now, this is on the equator, so Ecuador is off over here. We're just looking at the arrow. This is actual average wind speeds for the past 5 days. Pretty strong out of the east. Over the central Pacific, pretty strong out of the east. Over the Kelvin wave generation area, the West Pacific, this is where when the active phase of the MJO moves over the West Pacific, oh, and that's New Guinea there, it can dampen trade winds, and then that takes warm water that's typically here, pushes it off to the east in the form of a Kelvin wave, ball of warm water that traverses the Pacific, not on the equator, but under the equator, moving from west to east. Eventually, that Kelvin wave will erupt off of Ecuador and the Galapagos Islands up to the surface, create a slick of warm water there. If you have successive active phases of the MJO and successive Kelvin waves, that can help usher in El Nino, and that's exactly what we're looking for right now. All right, but we see trade's pretty strong across the entire Pacific, not suggesting any real signs of the active phase of the MJO. Now, we look at, but it's not the actual winds, it's the anomalies, the difference from normal for this time of year. Looking in the East Pacific, winds pretty much normal, maybe just a little bit stronger out of the east. Yesterday they were weaker, so maybe that's building a little bit. Central Pacific, winds pretty much dead neutral. In the Kelvin wave generation area, a little bit stronger out of the east, maybe suggestive of the inactive phase of the MJO, but you notice there's a big hole in the data right here, no arrows at all. And this is 160 east. When we get into the models here in a minute, you're going to see there's a big difference between what's happening on the east side from 160 versus what's happening to the west. So this is not a complete picture. We're looking at the wind forecast for the entire planet for the next week. And this is not the actual winds, it's the difference from normal. Are they stronger from the east or stronger from the west? So the blues are easterly anomalies, stronger out of the east. One can loosely say that's the inactive phase of the MJO, but you see, well, December 16th, it hasn't moved an inch. But what we do see is westerly anomalies, and we see them, they just creeped right into the picture. Oh, let's get the date line right there. Okay, remember we were talking about 160 east? That's right about there. Notice that all west of 160 east from 16th of December onward, very strong westerly anomalies consistently. And starting tomorrow, they back off. Any surprise that the jet stream is to start splitting and losing energy and not continue its massive push across the entire Pacific? Still strong over the West Pacific, but just this little bit of westerly anomalies not being present will only allow it to push maybe to somewhere around right in here, the jet stream itself, because it'll get interfered with these easterly anomalies down at the surface. It'll just lose energy and it'll split. All right, so what do we have here? The atmospheric river event that California has been suffering through, or had the pleasure of having, because at least it's making rainfall, started right around December 16th, 21st, somewhere in there, and has been going nonstop, and it'll likely wrap up in 2 days. The cause of it is these westerly anomalies right here. And so we're going to dive in a little bit deeper in a minute. Now, just looking forward, Kelvin wave generation area, dateline right here. The far West Pacific starts about we'll say 125 east, actually. So this box right in here is what we're interested in for the production of Kelvin waves. While we see westerly anomalies, that's very good for producing a Kelvin wave. That should back off some. We see weak easterly anomalies, bits of westerly anomalies. The real strong easterly anomalies remain locked, this line right here, about 160 east of there, at least for the next week. That's a good sign. All this suggests is that the jet stream will lose some energy and the rain will stop for California, but it's not enough to shut down the swell machine, we don't think. So let's look a little bit further out into the future. Outgoing long wave radiation model. It's just a projection for cloud cover. The oranges are less than normal clouds, more sunlight bouncing off the ocean surface. One can assume that's high pressure, the inactive phase of the MJO. And the blue here is less sunlight bouncing off the ocean surface. More clouds. We consider that the active phase of the MJO. And let's get ourselves oriented here. South America, Central America, Hawaii, EQ, the equator right there, dateline right up there. So active, and there's Hawaii, New Guinea right there. Kelvin wave generation area roughly right in this box right here. So today, active phase of the MJO moving east and out of the picture, inactive phase over the maritime continent. 5 days from now, you see it pushing into the Kelvin wave area, generation area, getting stronger 10 days from now, and stronger still yet 15 days out. Sure looks like the inactive phase of the MJO taking control. This is the statistic model. This is the dynamic model. We can see the two final frames pretty much painting the same picture. Notice a strong active phase building in the Indian Ocean. So the inactive phase in control probably for the next 3 to 4 weeks, something like that. It's pretty typical. It takes about, we'll say, anywhere from 4 to 6 weeks for any phase of the MJO to make it across the Pacific. So the active phase making its way out, inactive phase moving in. Okay, so if it's starting today, 6 weeks from now, it should be out of the picture, and this guy should be moving in. At least that's the theory. We'll see. All right, phase diagrams for the same two models. Statistic model, dynamic model. The heavy dot is where the active phase of the MJO is. In this chart, how do you read it? Well, the active phase moves west-east from the Indian Ocean to the maritime continent, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, or Africa proper, back to the Indian Ocean. You can see the past active phase weaseling its way around in December and January. I should say more like weaving its way. The heavy dot is where it is right now. So it's pretty much already out of the Pacific, somewhere in the Atlantic, approaching Africa. And if the dot is inside or near the circle, it's very weak. The forecast, 1, 2, 3 different tracks, one strong, 2 others weak, moving to the Indian Ocean 2 weeks from now. The dynamic model suggests pretty much a very strong active phase of the MJO building in the Indian Ocean, but not making it anywhere near the West Pacific yet. So one can assume if the active phase is on this side of the chart, the inactive phase is on the other side in the West Pacific 2 weeks from now, and that's a reasonable expectation. The upper level model generally shows, so the greens are areas favorable for precipitation, the orange is not favorable for precipitation, and normally you can track the MJO in relation to this. So let's get ourselves oriented. South America there, Central America, why that one little speck there, New Guinea there, the equator right there, dateline right there. One would say the active phase of the MJO is in the West Pacific, and I guess it is, but it's probably more over in this area. Anyway, this goes out 40 days. You see the active phase slowly sliding off to the east and into, or the area favorable for precipitation, and into Central America on February 24th, with the inactive phase here slowly working its way into the Kelvin wave generation area about a month from now, something like that. This model shows a much slower progression than what we saw on the previous model. Now we'll look at the CFS model. This goes out 30 days. This is, again, the east-west component of the wind. This is what I prefer to look at, though precipitation is a pretty good indicator, too. This also overlays the MJO. So we're going back October. And let's get oriented. Dateline runs right up the middle. Far West Pacific, about 125 east over here somewhere. Okay, Kelvin wave generation area in this box right here. Now, the solid contours of the active phase of the MJO. Okay, the reds, westerly anomalies. That's what we want. The blues, easterly anomalies. That's the trade wind enhancer. This is the trade wind crusher, the red anomalies. So we have a Kelvin wave that has pushed its way across the Pacific. I assume that is some due to the active phase of the MJO back here in October, the solid contour active phase. And westerly anomalies, you can see them, the reds, they seeped across the Pacific. Now, let's get back to what's been happening for California and the North Pacific for the past couple of weeks. Active phase of the MJO, westerly anomalies encroaching so well into the Kelvin wave generation area here, likely supportive of another Kelvin wave development. We'll get into that in a minute. Now, the forecast looking forward, westerly anomalies forecast continuing through about January, 20th or 22nd, something like that. Now notice the dotted contour here. That's the inactive phase of the MJO, with easterly anomalies weakly making their way into the Kelvin wave generation area. The remnants of La Nina, so here's La Nina, easterly anomalies just locking down the dateline. Still forecast to be holding, but notice they've given up ground. You know, westerly anomalies, you can draw this line, and it started even back in October. It was starting to make progress to about 150 east, something like that. For 2 years prior, they had not made any progress into the West Pacific at all. All of a sudden, a little pulse, another little pulse, a stronger pulse. Now we have, and the MJO itself was like pretty suppressed. If anything, it was just constant east anomalies. Now all of a sudden, the MJO is starting to wake up, and you get these active phases. Like, this is the first real active phase we've seen in 2 years that had significant amount of energy with it. And what did we get? Well, we got atmospheric river events nonstop in California. So we're going to get a little dry out here associated with the inactive phase of the MJO. But look, as we get into February, another active phase and westerly anomalies queued up. In fact, let's go look a little further out. All right, so this chart's reversed. Past activity is down here. The future is up here. But the same thing, dateline runs right up the middle. The blues are easterly anomalies, the yellows and oranges westerly anomalies. Consider that the active phase of the MJO. You can see the pattern real clear. We're back to September. Blue, 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 just locking down from we'll say 130 and everywhere east of there. But look at this line. As you get further in time, the blues are getting shoved off to the east, the easterly anomalies, and westerly anomalies are getting a better foothold in the West Pacific. Okay, and before we even say that, right there, here's our current westerly anomaly event. In fact, let's overlay the MJO. Okay, the red solid contour, active phase of the MJO. Why do we harp on the active phase of the MJO? Because when you get it, you get westerly anomalies. Now, here was an active phase back in October. We had some weak westerly anomalies. That produced a Kelvin wave. That Kelvin wave is pretty much the whole way across the Pacific now, and we'll get into the effects of that in a minute. This, we suspect, is building another Kelvin wave. And if you look at the forecast, if you thought that was strong and that was strong, I know the model overhypes it, but still, a very solid active phase of the MJO forecast starting about a month from now. We're at January 15th, February 15th. We should be starting to get into it. That's not too far. Now, I'm sure this model will downgrade a little bit, but still, look at this. Westerly anomalies pushing the whole way across the Pacific intact. Easterly anomalies completely gone from the Pacific. This would be a significant event, even if 50% of it happens, which we see seems to be likely. This model is doing a good job. So why is all that? Well, let's overlay the low pass filter. This shows low pressure and high pressure biases in the Pacific. The dotted contour, high pressure bias. No wonder there's been all this blue. In fact, maybe we can get the MJO out of here just a minute. You see the high pressure bias, and as it gives up space, well, let's just even look at this. Blues focused right over the high pressure bias, right? Moving forward, in fact, it started about December 30th. The trailing edge of the high pressure bias is starting to ease off to the east. The low pressure bias, the solid contour, we consider this the La Nina indicator, this the El Nino indicator. And if the Pacific starts right there, well, it's every one of these pushes of the active phase of the MJO eases the low pressure bias further into the Pacific. And notice this one here, a massive push of westerly anomalies and the low pressure bias into the Pacific is forecast. We're going to overlay the MJO here again. When we artistically waxed about the beating of a drum off in the distance, this is that drum. This is the first beat of that drum. This is the second beat of that drum. This is the third beat of that drum. And with each beat, it gets louder and closer to us, be it in Hawaii or California, and having more of an impact on the Pacific Ocean. Something is happening. A transition is happening. We will know for sure in about February, somewhere in mid-February. If this guy happens as forecast, one can say the beat of the El Nino drum is going to become pretty certain. All right, enough of the MJO, enough of all that. What's happening in the ocean? Not at the surface, but down deep. Down 150 meters is really where it all happens. Data from the TAO buoy array, again, that series of buoys strung across the equator. These are the anchor lines on the buoys. The X's are sensors on those anchor lines. They collect data about water temperatures down in the ocean. You use a model to stitch it all together, and you get a profile of where the warm and the cold water is across the Pacific. West Pacific here, East Pacific here. You see the 29 degree isotherm, this is in centigrade, there is none, but the 28 degree isotherm pretty much lock solid about 174 east, that's about where it was last week. The 26 degree isotherm, well, has been somewhere around 150, and that really hasn't changed a whole lot, but the 24 degree isotherm has pushed the whole way across the Pacific and is much deeper and thicker here, suggesting that warm water is pushing from the west to the east, or has pushed that way. In fact, this is the mean temperatures. Let's look at the anomalies, differences from normal for this time of year. We can see, in fact, a stream of warmer than normal water, just 1 degree, there it is right there, in the East Pacific. Now, there was cold water filling this whole area for months and months, driven by stronger than normal easterly anomalies across the Pacific. We won't beat that one to death anymore. But a Kelvin wave has crossed the Pacific, warm water developing there. That is why this line is getting thicker. There's more warm water here. Now we see the upwelling phase of the Kelvin wave cycle trying to develop here. The hope is that it doesn't get too big, doesn't get too strong, and do something like what happened. We'll look in a minute and see. But the other thing to notice, 5 degrees centigrade, that's what, 7 or 8 degrees Fahrenheit in the West Pacific, leading edge pretty much locked solid at 150 right there. That'd be 150 west, basically south of Hawaii. At some point, if the active phase of the MJO that we're in right now, if westerly anomalies were strong enough, which we think they are, you're going to see this water starting to surge east. Kelvin wave number 1, Kelvin wave number 2, and maybe Kelvin wave number 3, if you believe the models, is to come about a month from now. Here's another model showing the same thing, the remnants of Kelvin wave number 1, percolating or flopping, or sort of dissipating in the East Pacific. Massive, massive pool of warm water here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 5+ degrees centigrade, maybe 6 degrees in the East Pacific. The dividing line right there, 150 west. So the two models, though they vary in the details, the thickness of the stream right here, still suggesting pretty much the same thing. Another view of that, this is sea surface height. Maybe we can see it right there. Sea level anomalies. That is, these are not temperatures. This is the height of the ocean. Cold water of depth contracts. It'll create a divot on the ocean surface. Warm water at depth expands. It'll create a bump on the ocean surface. So this is satellite data. You strip out the waves, the wind waves, the tides. And is the sphere of the ocean higher or lower than normal? If it's lower than normal, we see pockets actually right here. The yellows is 5 centimeters above normal. That suggests warm water at depth. Again, warm water expands, it'll create a little bump there. So we see neutral to slightly elevated heights the whole way across the equatorial Pacific, suggesting warm water, that Kelvin wave we were talking about, right over in here. And again, the massive pool of warm water, there's the date line right there, there's the equator, poised. All we need is some westerly anomalies blowing over this area, and it'll push another spurt of warm water off to the east. Upper ocean heat anomalies. Heat anomalies in the upper 300 meters of the ocean surface. Going back in time, we're going back a year ago, we did have a Kelvin wave last year. It made the whole way across the Pacific. Then we got this cold upwelling phase. It held on the whole way through spring. We got 1, 2 active phases of the MJO, but they were really weak. They made a weak Kelvin wave that didn't even make it to the Galapagos. It faded. And then another massive cooling response fueled by La Nina and easterly anomalies over, well, where's the date line? Right there, okay? Just creating upwelling. And the whole while, notice the expanse of hot water and the intensity of the hot water has been building steadily for a year, actually for 2 years, suggesting that as La Nina has continued pushing easterly anomalies or feeding easterly anomalies, keeping all warm water balled up here in the far west Pacific, all it takes is just a little bit of a change in those easterly anomalies. They just have to weaken a little bit, and boom, the floodgates open. We think we're poised to do that. Here is the latest Kelvin wave, very weak compared to these other two, but one little Kelvin wave made it across the Pacific. We think, look at this, you can see right there, perhaps another is developing associated with the westerly anomalies that started somewhere right December 15th, we'll say, the whole way through now. Perhaps another Kelvin wave in flight. All right, so what's going on at the surface? Sea surface temperature anomalies. It's not the actual temperatures. It's the difference from what is normal, okay? The blues, colder than normal temps. The yellows and oranges, warmer than normal. The equator, right there. And it's only on the equator that matters. 5 degrees north and south of the equator. So basically from there down to about there. Now you look at this, you go, well, still there's cold water all over the equator. That looks like La Nina. Why? Well, there's high pressure here, and high pressure circulates clockwise in the northern hemisphere, creating easterly trades, creating upwelling. In the southern hemisphere, it rotates counterclockwise, feeding the same easterly trades, creating upwelling. But if you don't watch this chart day by day, week by week, you would notice that, well, yeah, these are colder, really colder than normal waters, but they're isolated to about 145 west, and they seem to be moving off to the west. And what was previously really cold water right here, well, is fading dramatically, and we have pockets of warming developing along the equator, likely in response to that Kelvin wave that's erupting in this area. Also notice we now have warming off of Chile, off of Peru, even off of Ecuador, and the extent of these cold waters to the south is getting progressively weaker and weaker. Just to illustrate that, we'll pull this over just a little bit. There we go. All right, so we're going back to January 1st, 2020. So what's that? 2+ years ago. Okay, things look pretty warmish, if not neutral. A little bit of cold air here, or colder than normal temperatures here. But then we go into June of 2020, and notice we started getting this cold signature developing on the equator, driven by enhanced trades north and south. The beginning of La Nina. As we got into January of 2021, a very clear and unmistakable broad cold signature off of Peru, Chile, Peru, Ecuador, the Galapagos, the whole way across the Pacific. Traditional La Nina, clear La Nina signal. We got into May of this year, still pretty much the same thing. Maybe we'll go back, let's look. Yeah, pretty much just a variation on the same thing. All right. Now we go to October of 2022. So what's that? 2 months ago, 3 months ago? Still just rock solid cold in control. Now we go to December 1st, 2022. Hey, wait a minute. What's going on here? There's a little bit of warming here. The cold down here doesn't look as cold. Let's toggle back and forth. There is October. There's December. What's going on? Well, likely it's the trades weakening. If nothing else, La Nina blowing itself out. Now let's go to yesterday and notice that. Look at the difference between that in December and all that cold water that was that really cold water. It's all gone. Warming here. The last of the cold water here. So we'll run the whole way through this. There we go. Oh, one more. Okay, here we go. From January 2020. The beginning of La Nina, the full La Nina in bloom continuing into May 2022, October 2022, and then all of a sudden a little bit of a weakening, and then a major weakening going on. All attributable to, well, here, let's see, where is the far west Pacific? It starts around, I'll say 130, something like that, 130 east. this area right in here, the Kelvin wave generation area, actually goes out to here. Westerly anomalies right here, tapping this warm water, pushing it off to the east. And that also, with the westerly anomalies building, it just seems to do something to the high pressure systems. They start losing energy. The jet stream starts building, okay? And then warming starts happening. The more warming you get all around the edges here, well, that starts creating more evaporation. High pressure loves cold temperatures, cold ocean temperatures. If the temperatures start warming, you start getting more evaporation. That basically cuts the legs out of high pressure, and that, we think, is the death of La Nina. Sea surface temperature trend for the past 7 days. This illustrates it great. I mean, the yellows and oranges are warming temperatures. Chile, Peru, Ecuador, Hawaii out here, the equator, you get the idea. Warming temperature. It started, well, 2 months ago, something like that. We started seeing patches of warming out here, just suggesting that the upper level or high pressure system was losing its grip a little bit. Not like this was being fed by a Kelvin wave or anything, just that the high pressure was losing its impact, trades were weakening, and so the sunlight was just starting to cook the ocean surface. Temperatures started rising, upwelling stopped, and now it's been like this. Look at this. It covers the entire, basically the entire equatorial Pacific, and more importantly, down here, this area right off of Chile and Peru really seems to be a major influencer. If you can get it warm down here, everything else seems to follow, kind of thing. And though it's not in the official El Nino monitoring region, that's this area right here from 120 west out to 175 degrees north and south of the equator. That's the Nino 3.4 region. This is Nino 1.2 here. And it's normally pretty noisy and erratic, but this has been in place, solid, for a month and a half, 6 weeks at least, something like that. We suggest this is an indicator of weakening of high pressure and also the death of La Nina. Now, this is the final view here, and again, showing the weakening cool temperatures. The Nino 3.4 region, right, the official El Nino monitoring region, right in here, okay? Still pretty cold waters in control. If anything, the cold water that was here is starting to build over in this area, in the western part of the Nino 3.4 region. And why am I harping on that? Well, let's take a look. Sea surface temperature, this is the sort of the index for the Nino 1.2 region, the area right there by the Galapagos and Ecuador. You see a steady from minus 1.6 degrees centigrade, steadily rising, and just barely the official threshold, though this is not the area that matters. The La Nina threshold, neutral, is at half a degree below normal. So if your temperatures are between half a degree below or above, you're considered neutral. If you're up in here, that would be El Nino-ish. But right now, minus 494 thousandths of a degree below normal, basically half a degree below normal. But this isn't the official El Nino monitoring region. This is. Temperatures here still sitting at 964 thousandths of a degree below normal, basically unchanged. Why do I pick on that? Well, that region is right here, okay? And you can see it's still basically colder than normal, so it wouldn't be surprising if the index was still showing colder. But all around it, everything's getting warmer than normal. The inference here is that this index right there at some point very soon is going to start ratcheting up. And the forecast models suggest that. We're just waiting for it to happen. So what does the atmosphere think is going on? We're looking at the Southern Oscillation Index here, the difference in pressure between Darwin and Tahiti. And it's that same deal. We talked about it last, well, let's do the tutorial first. Tahiti in the Pacific, Darwin over Australia or in the Indian Ocean. When pressure is lower in the Pacific, i.e. over Tahiti, the index goes negative. Hey, look at this. It was negative, well, 3 readings. Not particularly impressive. And looking back in time, it's been solidly positive for a long time. We got a little dent in here, but 3 days is not a trend when you go back a month. But the inference was, well, Tahiti, same deal. The west anomalies, the drop in pressure, all this stuff is going on in the far west Pacific. Tahiti's at 140 west. In fact, let's look at it. So Tahiti is right here, right? If the westerly anomalies and the low pressure bias is like over here, which is exactly what's going on. This is where all the action is right here, and this is what's feeding the atmospheric river. Tahiti here isn't seeing any of it because it's still solidly in the colder than normal temperatures where the remnants of La Nina are still in control. And the same thing for the Nino 3.4 sea surface temperature index. It's sitting right here in the middle of cold water, completely oblivious to everything that's going on around it. So you have to look at these indexes sometimes with a little bit of context. They do their job well if you know what's going on around them and why they aren't responding. We suspect that this index here is not responding, not because it's broken, it's just where Tahiti is. It's cannot see the change that's happening around to it. It's blind to it. But the suspicion is, in fairly short order, this daily index is going to start plummeting. The 30-day average SOI, it's just taking 30 days, averaging it all together, 20.32, still quite high. Actually higher than it was a month ago. No big surprise. The last of the cold surface temperatures are getting pushed to the west, right? Okay? And that in turn is keeping pressure high, but as soon as that warming signal starts reaching Tahiti, or westerly anomalies start pushing from the west there, either way, this index is going to plummet. The 90-day average here, that would be the La Nina El Nino indicator, 12.46 is positive. To get in El Nino territory, either one of these, they need to be negative, and we've gone nowhere. The suspicion is this index just is kind of useless because it's not in the right place at the moment. Either that or we're so dialed into the very early stages of that drumbeat that we were talking about. This is more of a conservative, and rightfully so, conservative value. It won't start reacting till much later in the process. So we're still early in the game. Here's the 30-day moving SOI just graphed out. If you're above 0, or we'll say above 5, you're in La Nina territory. If you're down below 5, then you're in El Nino territory. Of course, La Nina, not particularly good for surf production or rainfall or all that. El Nino gives you pretty much like we've been experiencing for the past 2 weeks in California, but only instead of 2 weeks of it, you get 3 or 4 months of it. All right, so the index today, sky high as it's been, suggesting La Nina. We know that is not true, or at least we suspect it is not, and we're going to get into that in a minute. But you see, it's starting to drop. The downward spikes are the active phase of the MJO. Upward spikes are the inactive phase. So the interesting thing is we're getting ready to move into the inactive phase. How far? Well, this is a 30-day average, so it's probably at least 15 days behind what's going on. So we'll probably see this drop some, then see it start to head up. But after that, we think a downward trend is imminent. All right, so what's going on? What is this? This is the forecast for the Nino 3.4 region, sea surface temperature anomaly forecast. All right, today is January 15th. This line right here is January 15th. According to this forecast, and this is the corrected one, we're not even going to look at the raw data because they both are telling the same story. And all the other models that forecast ENSO are basically saying the same thing. Sea surface temperatures start a dramatic rise, and by, 2 weeks from now, maybe 3 weeks, we should be in ENSO neutral territory. That is all warm water, the cold water in the Nino 3.4 region dissolving. As we get into March, we should be at dead neutral. As we get into July, temperatures just steadily rising up to, by October, 3/4 or almost 0.8 of a degree above normal, and the uncorrected one pushes it up more like 1 degree. That would be El Nino territory. Again, the reference to the drum metaphor. Everything suggests the continue building persistence and strength of the active phase of the MJO, creating successive Kelvin waves that then in turn feed this warming temperature pattern, which then drive us towards El Nino, not this winter, next winter, a whole year from now. We're talking a year out, but you can see it coming this far. In fact, typically during fairly robust El Nino winters, you start seeing the signs of it somewhere in the January, February timeframe. And typically you see it in the form of 1, Kelvin waves, 2, dropping SOI indices, and a improving building jet stream across the North Pacific, all of which we either see it happening now or we see it forecasted and are getting more and more confident that in fact it will happen. All right, so for right now, well, a little bit more rain, a little bit more snow for California, but give it 3 or 4 days. A dry out is expected, and the suspicion is high pressure will take over, split jet stream. At some point, the winds will settle down, but we're going to go through a bout of northwest winds in California. The center for storm production will move away from the Gulf of Alaska, move towards the dateline. Great for Hawaii. The jet stream still forecast to be quite strong for all models, and if you look at models that go out 2 weeks, out 4 weeks, they're all saying the jet stream raging to the dateline a little bit east of there and then splitting. So non-stop surf is expected. That's a good thing. And even for California, storms pushing over the dateline make great long period swell pushing towards the coast. If we can just get the winds tamed down a little bit, we suffered through south winds. Now we're going to suffer through north winds, but maybe a week or so out, that'll settle down. And then we could be in a really good place for swell. In terms of precipitation, California, both snow and water were, at least in central California and in the Tahoe area, pretty much near our seasonal average. And with the next Kelvin wave, or the next active phase of the MJO forecast in the February time frame, we would not be surprised to see another series of atmospheric rivers. That active phase is supposed to be even stronger than the one we've just gone through. So more flooding, more snow, more south winds, that whole sort of thing. So take this month to do what you got to do to clean up from the mess that we've just been through and prepare for the next one. And, you know, be thankful for what we've had. We've had a little bit too much of a good thing. Anyway, longer term, it certainly looks like the beat towards El Nino is happening. The drum is pounding. The signals are there. We'll know a lot more. Give it about a month. But if we get that next active phase of the MJO and sea surface temperature anomalies start warming and everything does like the models are saying, it seems pretty certain that we're moving certainly away from La Nina, and quickly so in the next couple of weeks, and towards a El Nino scenario for next fall. All right, that's all good news. We're looking forward to it. Be sure and like and subscribe, ring the bell. If you have any questions, I know a lot of detail here, just write them up. If you're thinking it, 10 other people are, we'll be sure to answer your questions. And we'll do this again next week, same time, same channel. Thanks for watching.